Hello everybody, thank you for joining me today. My name is Minam and today we're going to be looking at parallel circuits. So some of our learning objectives are to understand how resistance, current and voltage all vary in parallel circuits. Okay, so some things you really need to know are the standard circuit symbols because we're going to be using some of those in this video. If you do, let's get right into it. Okay, so now let's have a look at the three different properties for parallel circuits: voltage, current and resistance. First of all, we need to draw ourselves a parallel circuit. So let's do exactly that. Let's have a cell, and the way I always start drawing parallel circuits is I draw parallel lines. So say I want my resistor here and I want another resistor here. You can see that all three of these are all parallel to each other, and so all they need to be is connected up at their ends like this and like that. And there we have a parallel circuit right now. We have two resistors in parallel with a cell. Now, how does the voltage change across a parallel circuit? If our voltage here is 6 volts, voltage is the same across all components. So if the cell here is 6 volts, this resistor here is also 6 volts, and this resistor here is also 6 volts. They're all the same. Current, however, is shared across all components by resistance. So if these two resistors are the same resistance, say 50 ohms, and they will both get an equal share of the overall current because, well, they're both half the total resistance. Now, resistance in a parallel circuit, this is the one that trips up students the most. This is actually 1 over RT is equal to 1 over R1 plus 1 over R2. Okay, so that's a little bit weird, but to get RT on its own, we have to take the inverse of all the sum of inverses. So what we do is 1 over R1 plus 1 over R2, and then we put all of that in brackets, and then we do that to the power of 1 minus 1, or we can just do 1 over all of this, but this is how I like to write it, just so it's easier to see. This looks very complicated and quite difficult, but it's actually not. But what this boils down to is that for every additional resistor, total resistance falls. And that is the key point that you need to remember about resistance in a parallel circuit, and of course this formula here, which will help you. So right now, this equation here, this would settle to like this. So RT, well, hold on, let's do this. Let's mark this R1 and this one R2. So what I would do is 1 over 50 plus 1 over 50, and I can take 1 over that, or rather how I like to write is to the power of minus 1. That ends up being easier, and that ends up being 25 ohms overall, and that would be how you calculate the resistance of resistors in parallel. Now, if you understand that this is all quite new and might be quite confusing, but if you watch this video and the series video a couple times, I'm sure you'll understand it all.